Every time you pick up your phone or switch on a light, you're relying on metals. But look closely at that device. To get to this polished piece of technology, we have to start out here, in the dirt. How do we actually get from rough, muddy stones buried deep in the earth to the highly precise, glowing supercomputers running our world? That bridge is a specific science called metallurgy. It is the engineering discipline of extracting raw elements from their ores, refining them, and shaping them into exactly what we need. I'm a metallurgical engineer in the ferroalloy industry, and I'm going to take you through the specific chemical and physical processes that turn raw earth into high-performance materials. Without this science, there is no modern world. If you want proof, look no further than the massive steel skeletons holding up our cities. None of this infrastructure exists without the complex journey from earth to engineering. The first step in that journey is extractive metallurgy. Before you can build anything, you have to physically rip the metal out of the ground. This requires brute force. We dig up huge volumes, crush it down, and concentrate it. The scale of this operation involves moving thousands of tons of heavy rock just to separate out the usable material. Next, we have to isolate the pure metal from the waste. We do this through smelting, a process requiring extreme heat. By melting the concentrated ore, we trigger chemical reactions that pull the desired metal away from the useless rock. But extraction doesn't give us a finished, usable product. It just provides a chaotic, raw baseline of liquid elements. To actually use it, we need to refine our approach. This is where physical metallurgy comes in. We move away from the massive brute force machinery and shift our focus to careful observation. To truly understand a metal, engineers look at it through a microscope. We have to map out its hidden internal microstructure. We test these microscopic samples to measure their strength and hardness. We watch exactly how the internal crystalline lattice warps and behaves when put under severe stress. By pushing that tiny microscopic structure to its absolute limit, we figure out its precise breaking point. If we don't map out this exact internal blueprint beforehand, massive engineering projects, like a suspension bridge carrying thousands of cars, would eventually fail from unpredictable material fatigue. Once we have pure, rigorously tested metal, we have to force it into usable shapes. We call this mechanical metallurgy. This relies on immense pressure. Processes like industrial rolling involve squeezing red-hot metal through heavy rollers to press it into precise structural geometries. The underlying physics here are as old as a blacksmith striking an anvil. It takes massive kinetic energy to make hard metals formable. But what happens when we need a shape that is simply too complex or delicate for heavy forging? That is where powder metallurgy takes over. Instead of melting or hammering, we process the metals into a fine dust. We then compress that powder under intense pressure to create highly precise, intricate components for electronics and aerospace engineering. These shaping and compacting techniques act as the final bridge. They take the isolated elements we pulled from the dirt and mold them into the working parts that run our machines. Let's pull back from the microscopic powder and the roaring blast furnaces and look around. To build a single complex machine, like the polished aluminum of an aircraft, you need the complete earth-to-engineering cycle. You need extraction, chemical refinement, and precise mechanical shaping. My work managing furnaces and molten metal every day is a constant reminder of the sheer industrial effort required to sustain our way of life. And this is just the start. In upcoming videos, we will dive deep into exactly how these massive furnaces operate, map out chemical metal reactions, and explore the hidden engineering secrets of the industry. If you want to understand the science powering the world around you, hit like, share, and subscribe to Metals Beyond Matter. Every bridge we cross and every device we use proves that metals are the essential framework of human progress.